So to continue on here, just if you have a picture, we want to be able to identify what type of angle pair they are. So here's angle 4, here's angle 5. Notice they're on opposite sides of the transversal. So they are alternate, and they are between the two lines, so they are interior angles. Okay, so if I'm going to compare angle 5 to angle 2 for part B, they're on the same side of that line. They're on the same side of the transversal. So they are, but they're one interior, one exterior. Those are corresponding angles. Okay, corresponding angles. And so if we are looking at angle 3 and angle 5, angle 3 and angle 5, they're on they are same side interior. They're interior in between, but they're both on the same side of the transversal. So remember, consecutive interior or same side interior are the two different ways those are referred to. Okay, so then if we have angle 2 and angle 7, they're on opposite sides of the transversal, so that's alternate. They are outside of the two lines, so alternate exterior angles. So sometimes you just have a little bit bigger picture going on. There's more going on. It's kind of hard to read those names of those lines, so I rewrote them. So the directions here ask us to identify the transversal and also tell me what kind of angles they are. So if I'm looking at angle 1, so I'm going to use the highlighter here. If we have that, to make angle 1, I need to highlight line U and line M. The other angle I'm looking at is angle 5, which means to finish off angle 5, I need to highlight line O. So if you can just look at the highlighted lines and try to ignore the rest of the picture, those are on the same side of the transversal. Well, U is the transversal. Okay, U is the line that crosses the other two of the ones that are highlighted. They're on the same side, but they're also both above, so that's corresponding. Okay, so we just kind of do the same thing depending on which lines we're looking at. If we want angle 4, angle 4 is this one here, so I would need line U again and line M. That's kind of messy. But angle 4 is right here. Okay, angle 8 is way over here, so I have that top line for angle 8. To finish off angle 8, I would need to highlight this one. So I've got S, U, and M highlighted. The transversal would be line M. They are on opposite sides of line M, so they are alternate. They are outside the two lines of exterior angles. So if I'm going to do angle 3 and angle 5, here's angle 3, which means line M and line U again. And I need angle 5, which is down here, so I need L to finish it off. Same side of the transversal being U, so those are same side interior. Same side interior. And if the picture gets really crazy, we'll just do a couple of these. So there's a lot going on in this picture, especially with all three lines intersecting up there. So you have to be able to, if we're looking at angle 6 and angle 11, again, you really just have to be able to focus on try to focus on those three lines and just ignore this part of the picture. Are those alternate interior angles? Yes, yes they are. Okay. If I'm looking at 4 and 9, I want to look at these two, so I need this line and this line. So I want to ignore anything over here and try to just look at green. Those are not alternate exterior. They're on the same side of the transversal. Those are corresponding. Okay. And that's not something we run across too often. I think we're fine to move on. Okay, so we have some postulates that are going on here. if two parallel lines are cut by a transversal, each pair of corresponding angles is congruent. So now, notice these things are, these next postulates are all starting with if two parallel lines are cut by a transversal. If two parallel lines are cut by a transversal. So now we're talking about they must be parallel. So when lines are parallel, then special things happen because they are parallel and that other line, you know, we don't have to say straight line. When you say line in geometry, they are straight. Then we have angles that are the same size. Okay, you know, we know vertical angles are the same size. If I just number these, however, okay, it says any pair of corresponding angles is the same size. We know that 2 and 5 and are the same size. Okay, we know that angle 1 is going to be the same size as angle 6. Okay, in fact, we would only have two different angle measures. If you have parallel lines cut by a transversal, if I tell you the measure of one of those angles, we would know the other ones all very quickly. If I tell you that this is, we'll say 120 degrees, we could figure out all of the others quite easily. The linear pair would have to be 60. The vertical angles are congruent, and so that would be like that. Well, that same situation that is going to happen down here. Okay, because it's all the same angle. Once you have one number, it's either that, every other angle in that picture is either that number or the supplement, 180 minus that number. So that's what this is saying here. Corresponding angles are congruent if you have parallel lines cut by a transversal. Okay. If you have parallel lines cut by a transversal, alternate interior angles will be congruent. Okay, they're the same size. These two angles are the same size. These two angles are the same size. Okay, the two orange ones are the same, the two blue ones are the same. Consecutive interior or same side interiors are going to be supplementary. They're not the same side. Let me make that transversal really slanted so we can really see what's happening here. So, same side interior, we got this one and this one. Those are not the same size, but they are supplementary. Okay, they would add up to 180. If this one is 20, this one's going to be 160. You can do 180 minus that to come up with that other number. Alternate exterior angles with parallel lines are congruent. So if you have alternate exteriors, those two angles are the same size, the two red ones, and the two green ones would be the same size. So all of that depends on the lines being parallel, though. You have to have parallel lines for that to be the case. Okay? And this is really more of a extension off of one of those. If you have two parallel lines, okay, if we have a line, this one here, if it's perpendicular to this one, then it must also be perpendicular to the other. And it's really just an extension. The corresponding angles would have to be congruent. Okay, you could get there lots of ways. So it's really sort of a special case of the previous ones. Okay, so again, if you know one measure, you can find all of them very quickly. So let me do one that's not quite as, well, let's see, let's say if angle 2 is 37 degrees, we need all of the others. Okay, well, I know the vertical angle, I'll do the ones we're getting in blue, has to be the same. So angle 3 has to be 37 degrees. Okay, how would I find 1 and 4? I need to do 180 minus 37, which would be 143. 143. So these two are 143s. Then what I know is down here with 5, 6, 7, 8, they're exactly the same as those. 143 and 37. 37. Okay? Let's just rewrite all of them. Okay? Following diagram, find the measures. So again, if I get this one is 65, don't go by looks, because that one looks to be obtuse, but if I say it's 65, then this is 65. 180 minus 65 is 115. So then this one is 65, and this one is 115. That diagram is not drawn to scale. Okay? Use properties of parallel lines to find x. Again, this tells me that they're parallel. So then you kind of have to think about it. Well, this is 125. 180 minus 125 is 55. So that's how this intersection is looking. So what about that x plus 15? Now you have to do a little algebra. Is it a 155 or 125 or a 55? Well, it's in the same position as this one. So that's a 55. And then we can solve the equation just like so. Okay, and x equals 40. Okay, I would do exactly the same thing here in example 3. Every angle in this picture either has to be 72 or 108. So the x minus 8 is, that's the same as this one, would be a 108. So far solving for x, and x would be 116. Okay, so sometimes again we're going to use these properties. We can, work our way through. It's not just that line going on. So down here we get a 70, which means that's a 110. Now, if we think about, we got our parallel lines, so depending on how we think about this transversal, so alternate interiors means this one would have to be 70. Okay, now what we know up here is that all three of these put together make a straight line. So the x minus 20 plus the x plus the 70 have to add up to 180 because they make a straight line. We combine like terms. Now we gotta remember some algebra here and solve for x. 2x equals 130 divided by 2, x equals 65. Okay, and almost done. And if we have angle 5 is 2x minus 10, angle 7, okay, so we're looking at angle 5 and angle 7. That way we know that those are corresponding angles, so algebraically we just set them equal to each other. Subtract x from both sides, add 10, 25. Okay, if we're going to do angle 6 and angle 8, those are not the same size, which means they would have to be supplementary. So instead of setting them equal to each other, I would add them to get 180. So 4y minus 100 plus 4y equals 180. 8y minus 100 equals 180. Add 180 to both sides, or 100 to both sides, and divide by 8. I think that's 35. Okay, and just like I said, you can try to ignore part of the picture. So this is what we often gets referred to as the crook problem. And sometimes what you have to do is actually add something to the picture. If I add a third parallel line in there, then by looking at two particular ones, if this is 63, this is 63. And then in the same fashion, if this is 31, this is 31, just looking at the bottom half of the picture. So then if I want the x, it's the combination of the 63 and 31, and it would be 94. Okay?